Welcome back to Blue Collar Coder. I'm Jack Harrington, and today we're going to take a look at 3 different rendering methods for React. The first is client-side rendering, which you're probably familiar with if you've ever done a Create React app, which you probably have. The second is server-side rendering, which you'd be familiar with if you've done content pages or e-commerce, or if you're familiar with SEO, search engine optimization. The third is static site generation, which is something that we've learned a lot about with the advent of systems like Gatsby. So why now? Why this topic right now? Well, NextJS has come out with 9.3, and that platform now supports all 3 of these rendering modes in a single platform, which makes it great for building a video like this. Otherwise, I'd have to use 2 or 3 different platforms to do this. Now I get to do it with just the one and walk it all the way through it. So here's what we're going to do. We're going to build a simple Pokemon app. It's going to have an index page. There's a search field. Type in some characters and you find out, here are the Pokemon that match that. That's going to pretty much stay dynamic through the whole thing and client-side rendered. But when you click on one of those, that's going to take you to a detail page. It's going to have a picture of the Pokemon and some stats. And that we're going to experiment with in different rendering modes. And we'll just walk right through all those rendering modes and you get a sense of how they all play out. So let's start this out by talking about what client-side rendering is. So in the client-side rendering model, the server renders a blank page along with a reference to a JavaScript bundle. That goes up to the client. The client then renders a blank page and then starts interpreting that bundle of JavaScript, which is probably your React app. It finally executes that. That React creates some DOM elements. They get put on the page and boom, there's your UI. So that's how client-side rendering works. Let's jump into the code and start it out. All right, so here's the Next homepage, and Next is what we're going to use for all of this. And here's our example app. It's a searchable index of Pokemon. So the home page is a search page. And then once you click on one, you go to the detail page, and that's got the Pokemon image as well as some stats. For the UI, we're going to use React Bootstrap. So the first thing we're going to do is create a directory called Pokemon Next. And then within that, we're going to use npx create next app to create an app called CSR. That'll be our client-side rendering example. Once we're done with that, we're going to bring in all the Pokemon images, as well as the Pokemon JSON. Now all that's in GitHub, so you get that for free. All right, let's bring up VS Code. And now you can see we've got a Pokemon directory within public that's got all the images and also a Pokemon JSON file. Okay, let's add Bootstrap and React Bootstrap. So now this is our home page. It's built out of the box by Next. So let's change out the title, the Pokemon, and then get rid of all the content really. Now we're going to bring in a container from React Bootstrap and fire it up. Okay, looking good, but we don't have the Bootstrap styling yet. So let's go over and create an underscore app file where we can include the styling and then just give a kind of pass-through component here. Okay, looking good. Now we have the right font. So the next thing we want to do is create a search API. So this is going to be the underlying API that's going to give us back the list of the Pokemon that match a query string. And in Next, all you got to do to create that is first create a directory called API. And then within that, anything is going to be considered an API. So we're going to create a search.js file, and it's going to include the Pokemon. And what it needs to do is export a default function that takes a request and a response. And by default, we're just going to return status 200. Yay, we win. And then also set the header to application JSON. We're going to give you back a JSON payload. And then we end the response with a JSON stringified hello. Great. Looking good. Okay, so now we actually have to do something. So let's go ahead and get the query string. So that's going to come in as rec.query.q. And if we get one, then we're going to create a regex out of it. So that's what the new regex is with the query. And then the I means case insensitive. And then with that, we are going to go and filter all the Pokemon. Now, Pokemon have a name field in it with an English variant. So we're going to say, well, if the English matches our filter, then there you go. And we're going to take a slice of the top 10 of our Pokemon. All right, so this is showing us a Pokemon data structures that we got back out of the JSON file that match. So you've got an ID, you've got a name where it's got a couple of different variants, And then you got the type, which I guess in this case you got grass and poison. And then base has all the combat stats for that Pokemon. Okay, so that's looking pretty good. Next thing we need to do is create an input field. So bring in a form control. And we'll get a query value, but we need to track that in the state. So we're going to bring in use state from React and then set that all up. Okay, looks good. So how are we going to go and get that data? Well, I think we should use Axios and React Query because they're really nice and they play really well together. So the first thing we're going to do is create a get Pokemon function. It's asynchronous because it makes a request. And it's going to take a key and a query. We'll get to that in a second, but the Q is the query string. And then we're going to use Axios to make that call to the API, get the data back, and then we're going to return that data. Of course, we need to import Axios. That'd be good. And next, we're going to use the use query hook from React Query. And all you got to do there is just create the hook. And then you give it an array where you got the key and value. And then you give it the handler that's going to go off and make that request. And you get back data, as well as a bunch of other stuff. You get error and is fetching and all that as well. We're just going to use data. Okay, now as I type, you can see that we're making the requests. So that's good. Now we just have to format that data somewhere. Okay, so first we're going to stringify it and just drop it in there. Looks good. Next thing to do is add a little bit of formatting. And we're going to create a row. And then within that, for each one of the Pokemon, we're going to create a card. And that's going to be it's going to be a 3-column layout. The XS4 means that you are taking up 4 columns of a 12-column layout. So that gives you 3 columns. And then we're going to bring in that card, just put a name in English and the subtitle of the type, I guess, where we'll join it all together. Oh, looking good. Okay, so we can start typing, and that looks great. Finally, we just need to bring in the image. And the easiest way, I think, to do this is to go and just kind of augment the data coming in with an image. So we're just going to create one that's /Pokemon, which is where it is in the public directory. And then we're going to change the English name so that it's lowercase and all the spaces are replaced with dashes. All right, let's drop that in there as the image. Okay, looking really good. So next thing to do is to create a link to a detail page. And that's going to be the /Pokemon/name in English. And we click on that and it's 404, right? We haven't built it yet, so that makes sense. So here's how you do that. You're going to create a new folder. It's going to be Pokemon because it's /Pokemon. And then within that, you're going to create a file called open bracket name close bracket.js. And that's going to basically tell Next that whatever comes after Pokemon /Pokemon/Ivysaur, whatever, that Ivysaur is the name. And then Next is going to pass that on to us as part of a route. So we're going to import the use router. And then NextJS is going to bring that to us as part of the route. And then we'll use router and go and get the router. And then within the router, it's going to be router.query.name. Okay, cool. So now we're getting Bulbasaur. So the next thing to do is actually go and make the request to the server to go and get everything about the Bulbasaur. But how are we going to do that if there's no endpoint for that? So let's imagine that we're going to have this /API/Pokemon where we get a name and it's going to give us back a single result. All right, so let's copy over the search because, a lot of it's going to be the same. Look for name. And we're going to say if we don't have a name, then we're going to 400 out. Look at us being really good with our status codes. And then if we do have a name, well, we're probably going to be at 200, but let's go and check that by first doing a filter on Pokemon to see if we find one. And then if we don't find one, we're going to 404 because the resource is not found. And otherwise, we're going to go and send back the 200 with just that one Pokemon. Because filter just returns an array, so we're going to take the 0th item off that and return that as the data. All right, let's try it out. Okay, looking good. Got Bulbasaur in there. So let's go back to our page. Now we've got our API running. That's awesome. So we're going to bring in use query, add that name, get that data. Now we're just going to return that. Now we've got, and for the moment, we're just going to show the ID. That shows up, small, but it's there. So that's telling us 1. Bulbasaur is number 1. Okay, so let's actually make a good looking page here. Bring in a bunch of the Bootstrap stuff. Add a head with the name of the Pokemon. And then I create a container where we've got the name as an H1. Beauty. Looking good. And now within that, we're going to create a 4-column row that's got the image. And then we're going to create an 8-column row that has all of the base values in it. I'm just going to copy and paste that in there for time. Object.entries is really nice in this context. What it's basically doing is it's taking an object, that's that data.base, isn't just an object with keys and values, and it's turning it into an array of arrays, where the arrays within the array have the first value as the key and the second value as the value, and that way in our map, we can just bring it in as an array. We can kind of parse that back into key and value again, and then just drop that in the row and then in the columns. Really nice. Take a look and see how that looks. Great. Awesome. So it's a fully client-side rendered application. There's nothing happening at the server side on a request besides creating this blank page, and then our React on the page takes over and does all the rendering for us. So that's the client-side rendered version of our Pokemon app. Let's talk about some pros and cons. So on the pro side, it's very fast for the server to vend a blank page. Another big pro is that you can statically build these sites. You can statically build the HTML, the CSS, and the JS, and then deploy that out to S3, and then you're serving off of S3. You're not serving off of a server, so you can sleep well at night. And I would say the biggest pro of all is that it supports single-page applications. No other model supports single-page applications, so if you're going to do a spa, you're going to want to use client-side rendering for that. Now, on the downside, the biggest problem is that you're vending a blank page to the customer. And until that React app loads, they're going to see a blank page, which is not great. Particularly since compounding that is the fact that bundle sizes can be large nowadays. And so particularly on slow connections, that's going to be a problem. Let's talk about server-side rendering and how that model might fix it. Server-side rendering starts the same way. We get a request from the client. The React is then run on the server, and that creates 2 artifacts. The first is some frosted state that goes into a script tag in the head, and then there is the HTML that's generated from the DOM that's been rendered on the server, and that goes into the body. That goes off to the client then, and the web client, because it's got some HTML, starts rendering, starts putting something on the page right away, which is great. In addition, that JavaScript bundle for the React is run. There's a rehydration phase that takes that data that was put in the head and then sets up your state. Your React app gets run, that generates a VDOM, those two are reconciled, and you're good to go. So let's go see how to implement that in Next. Okay, picking up where we left off. We're going to shut down that server, and then we're going to copy that CSR directory into a new directory called SSR. And then I'm just going to refetch the node modules just to make sure that everything's good. Bring it up in VS Code. And I'm going to go over to the NextJS documentation site around data fetching. So what we're looking for in this case is get server-side props. And we're going to take this function, and we're going to put it into our detail page. That's the bracket name bracket.js file. Just make sure though, let's fire it up first. And now let's look at the page source, and you can see inside here, so as you can see, there's nothing inside of that underscore next div, which is where the app's going to go. If we were to disable JavaScript and try to refresh again, you get nothing, because without JavaScript, you're not going to get any page. So let's go and add the server-side props to go and get the data first. Now with this, we're just going to call get Pokemon, and then we're going to give it the params name through the context. That's what comes in on the server-side props. And then we're going to give that back as a prop. Interesting thing though, so we tried from the server to hit /API directly. Well, that's not going to work because you actually need the host name. So we're going to put in there localhost 3000. It's basically going to call itself. And now if we look at the page again, you can actually start to see some SSR happening. So this next data block is basically the frosted state of the page, and that's coming out of that get server-side props. So those props are going to the component, we're just not actually using them yet. So let's try that out. We're going to bring in data, and we're going to basically just say, hey, don't worry about it. We've got this. You don't need to use any router. You don't need to use any query on the client side. Now let's run it again, and it looks great. If we go back into the inspector, and we take a look at the page source, we can see that we actually have HTML tags in there. And if we go over and we disable JavaScript again, and we reload, well, we don't get a beautifully formatted page, and I'll go into why that is in a second, but we do get a page. So why don't we get the beautifully formatted page? Well, here's the reason. We're actually bringing in our CSS as in the JS block. If we imported our CSS as basically just a flat, kind of style tag, it would render just fine. So that's something to look out for. And that's it. That's all it takes to do server-side rendering in NextJS. How cool is that? So that's the server-side rendered version of our Pokemon app. Let's talk about some pros and cons. On the pro side, the content is immediately available, meaning that you got those tags, the browser is going to start rendering immediately, which is going to look great on slow connections. In addition, there's no additional fetches from the client. We're not going to make any additional API calls back from the client to the server, so the way a client-side rendered app or a SPA might. So there's a big advantage there. And then finally, it's really good for search engine optimization or SEO. It means that the search engine doesn't need to execute your JavaScript in order to understand what might be on the page. Now on the con side, it is slower for the server to do this. You're basically rendering your app twice, once on the server and once on the client, and that can take up a significant amount of time depending on how complex your page is. In addition, some UI frameworks can be incompatible with server-side rendering because they look at window, which is not available in the node context, so that can be a problem. All right, let's take a look at static site generation and how that might fix or alter the equation a little bit. So static site generation changes the equation significantly. It moves the render process off of the server and into the build process. So what happens is that Next.js will request a list of all the pages that need to be rendered at build time, and then it will build each one of those pages individually and store those off into files. You then take those files and deploy them to S3 or any static asset hosting site, and there you go. You've got your site. So let's go try out static site generation in the context of our Pokemon app. Okay, so again, picking up where we left off, we've got our server-side rendered app. We're going to go back into VS Code, and we're going to shut that one down. And we're going to copy that into an SSG directory. And that's going to have our static site generation app. So again, I'm going to refresh node modules, go back in here, fire it up, and let's see, looks good. So let's look at data fetching. So in this case, we're going to be looking at get static props and get static paths. So what get static paths does is it tells Next.js what the entire list of all the paths that should be rendered. And then get static props is effectively get server-side props. It's just for the static side of the house. So let's start off with get static paths. So in this case, we're not actually going to go and use the API. We're just going to go directly to the Pokemon JSON, because you got to figure at build time, right? You're going to have access to the data. You're either going to have access to like a database or flat files or something. You're going to have access to that data. You really don't need to be calling APIs. I mean, you could, but you don't have to. And then the first thing we're going to do is we're going to tell it the fallback is false. We don't want any basic fallback page here that would capture anything that's not listed. We want everything that's not listed to just be a 404. If we don't know about that Pokemon, we're not going to be able to tell you about it, so it's a 404. And then when it comes to paths, we're just going to go and grab out that English name, put that into props as the name. Cool. And the next thing to do is to get that static props. So let's go and grab that. All right, now because we got the Pokemon, we might as well just use it. So we're going to go and set the props data based on whatever we get in as a context. And we're just going to filter through it, get the right name, and take the 0th item of that. We're going to fire it up. Oh, and I messed up. It's params, it's not props. Okay, fine. That makes sense. Comes in as params, right? All right, fire it up. And it looks good, looks great. So now, you're not ever really going to be doing, you can dev that, that's fine. But what you really want to do is use that as part of your build process. So let's do yarn build. And what you can see is we're now doing a bunch of static site generation, including creating 806 paths for the different Pokemon. So if we look, there's now this temporary file for the Ivysaur HTML. Let's take a look at that. And we can see that it's all rendered out in there. Okay, let's now start it up. Instead of doing yarn dev, we're going to do yarn start, and that's going to be just like you do in production. So in this case, you're still going to have a dynamic or client-side rendered index page, but all of your detail pages are going to be statically generated. So now if we go and take a look over the network tab, we can see that the page itself is vending in 4.44 milliseconds. That's really cool. That's insanely fast. Just as an example, let's go over to that SSR page and try that again. So again, we're going to do the yarn build. Now you can see this time we didn't go and build all those static files. So we're going to run that again. And this time, we vend that page after server-side generation in 125 milliseconds. So it basically takes 125 milliseconds to go and do all that work. And that's just on the server side. That's before you send it off to the client. So you can start to see right away the value of having those statically generated files. And not only that, but you could drop all those statically generated files on S3 and you'd be good to go. You don't actually have to worry about the server for anything other than that index page. And if we take another look, comparison-wise, let's fire up client-side rendering. And we can see that that one runs in 22 milliseconds. Again, and that's just because it's rendering a blank page. Right? Blank pages don't take long to render. So yeah, you're going to get a really good performance server-side render-wise with client-side rendering. But if you turn off JavaScript or whatever, then you got client-side rendering problems. So there's pros and cons. There's pros and cons to everything in this system. So there's the statically generated version of our Pokemon app. Let's talk about some pros and cons. Now, the pros and cons actually share a lot with server-side rendering, but let's go through them anyway and then add a few more. So first, just like with SSR, the content is immediately available, meaning it's really fast on slow connections. There are also no additional data fetches from the client. It's not like SPAs or CSRs. And it's great for SEO because, again, you've got all the HTML there. But here are some new advantages. It's incredibly fast to serve, as we've seen. Static site hosting sites are much faster than ever calling a server. And you don't have a server, which is great. You don't have to monitor anything. You can be able to sleep at night. It's awesome. So what are some of the cons? So it can be slow to rebuild on large sites. Right? If you've got a large manifest of files, that can be a problem. And also, as with SSR, you're going to have some incompatibilities with UI frameworks that are going to be looking at window. But that's not a big deal. Those bugs are actually pretty easy to fix. So let's talk about some heuristics when you might choose one of these methods over another. So for CSR, so what would it be good for? It'd be good for logged in experiences. Anytime that you need to know the customer, like a bank account or something like that, you're never going to render a page like that without understanding who the customer is. So it's great for that kind of scenario. It's also really good for single page applications. It's really the only way to do single page applications. It's great for proof of concepts and where performance is not necessarily all that critical. So I would pick server-side rendering or SSR if I had requirements like SEO support or pages on loading fast on slow connections. And I would go with static site generation if I had those type of requirements and also a fairly slow moving page set, like for example, the product list from a e-commerce site. All right, well, I hope this video was helpful and informative. And if you liked it, please hit that like button. If you really liked it, hit that subscribe button, ring that bell, and you'll be notified anytime a new one of these videos comes out. In the meantime, be happy, be healthy, and be safe.